A new AI can now reliably operate across all your digital devices, handling complex tasks and improving itself. This could mean your computer and phone become truly autonomous assistants. Let's get into it. Let's start with a featured paper. Qwen-UI-Agent Technical Report Toward Next-Generation Real-World Centric Foundation GUI Agents by Alibaba Token Hub from Alibaba Group. Qwen-UI-Agent outlines an ambitious and comprehensive vision for next-generation GUI agents, addressing critical real-world challenges like cross-platform operation, long-horizon tasks, and autonomous improvement, making it a potential frontier model in this domain. Here's a full breakdown.
Starting in Panel C, we introduce a hybrid action space that combines traditional GUI actions like clicking and typing with powerful CLI actions. This unified process allows the agent to fluidly interleave both types of operations within a single thinking step. Feeding into this, Panel A shows our self-improving data flywheel, built around a repeat and recover loop. The agent autonomously attempts tasks, diagnoses its own failures, and synthesizes new data to improve over time. Next, to power this learning loop, we utilize the ENV scaling capability shown here. This allows us to run training on over 10,000 concurrent sandbox environments, which is crucial for learning from long and complex task trajectories. Finally, this all enables a unified interface for heterogeneous environments, as shown in Panel E. A lightweight harness layer creates this sharing space, allowing the agent to seamlessly think, act, and observe across different devices like mobile phones and computers. Qwen-UI-Agent consistently outperforms other methods like Seed 2.1 Pro, GPT 5.6, Sol, and Claude Opus 4.8 across most benchmarks, including Mobile World Real, Android Daily, Web Arena, and ScreenSpot Pro. While it achieves the top score in 5 out of 6 benchmarks, it is slightly surpassed by Claude Opus 4.8 on the OS World Verified benchmark.
Up next, our second paper out of 3, Bunraku, turning a single illustration into an editable live 2D character by Juanhao Chen and Rookie Huang from Tsinghua University. This paper presents a significant advancement in automating the labor-intensive process of creating live 2D models from a single illustration, addressing a clear pain point in a widely used animation format. Let's break down its key contributions.
First, we take a single input illustration and, in Stage 1, use a set of live 2D aware conditions to guide a denoising backbone. This process decomposes the image into a stack of distinct parts, like the hair, face, and clothes, resulting in the layered RGBA output. Next, in Stage 2, these layers are converted into meshes and their features are constructed, which are then fed as a single sequence into our joint multi-layer transformer. This model uses interlayer self-attention to predict how all the parts should move together for a given key pose. To enable and evaluate this entire process, we introduce Live 2D Bench, the first standardized benchmark for this task. This benchmark is built upon our massive new Live 2D corpus, which provides the rich, structured data needed for training, such as the live 2D taxonomy used back in Stage 1. The proposed method, labeled Hours, consistently generates character animations that are highly faithful to the ground truth, GT, across all shown examples. It substantially outperforms baselines, such as 1.2.2, I2V, and CogVideoX. I2V, which exhibit noticeable distortions and color shifts, while producing results on par with or slightly better than on eDoc.
Up next, our third paper out of 3, Sample More, Reflect Less, Self-Refine and Reflection Lose to Repeated Sampling at Equal Token Cost from 1.5B to 7B by Aliyah Mirzai from Stony Brook University. This paper challenges the prevailing assumption that complex self-reflection and planning methods are superior to simple repeated sampling, demonstrating that at equal token cost, sampling often outperforms these more elaborate techniques, which has broad implications for LLM efficiency and strategy. Let's break down its key contributions.
First, let's look at the bottom of the table, where we establish our strong sampling baseline. This method generates a pool of 16 answers and then picks the most common one, giving us a cost of up to 16 model calls. Feeding into our comparison, we evaluated a wide range of existing approaches, listed here in the method column. This includes everything from simple chain of thought to more complex strategies like self-refine and multi-agent debate. Next, to ensure a fair comparison, we meticulously track the computational cost for every single approach. This is all laid out in the model calls per question column, which accounts for every generation, including internal critiques and revisions. Finally, the results derived from these experiments aren't just raw numbers. We applied rigorous statistical analysis, using techniques like bootstrap intervals to ensure our conclusions about which methods perform best are truly reliable. Self-consistency at N consistently achieves higher accuracy on both GSM 8K and math 500 benchmarks as the mean completion tokens per question increase. It generally outperforms other methods such as chain of thought, reflection, and self-refine, particularly at higher token budgets.
Those were the top papers. Now let's zoom out. ArXiv received 711 new computer science papers across 61 subfields today. Here are the trending areas shaping the field. Zooming out, the day's research clustered into three big themes: multimodal AI for specialized domains, decoding and counterfactual AI learning, AI for health and research systems. The full paper list is in the pinned comment below. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please like, leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.